Hello everyone, am I audible and are the slides moving? Thank you. So good afternoon everyone. I welcome you all to Dr. D.Y. Patil Vidyapit Center for Online Learning, and we are already learning the content from Unit 2. So that is a measures of central tendency, and in this session I finished the remaining part of this unit and will learn the Unit 3, that is measures of dispersion. So measures of central tendency, what is the meaning of this? Measures of central tendency, in this you want to know a single number which is representing your number, your whole data. Okay, so we have already learned about the arithmetic mean, and now we have also seen the concept of the median. So we'll see the calculations for the median. Again, I shall repeat what is the median, then we go to the mode, then we go to the third unit, and that is the measures of dispersion. So let's start with the median now. So what is the median? Median is the middlemost observation. Middlemost observation, 50% of observations are lying above the median and 50% of observations are lying below the median. Okay, it is also known as a middle score or 50th percentile. What is the meaning of this? If you have a data and you want to divide your data into two equal parts, in how many points you require to divide your data in two equal parts? You just wanted to know a single point which can divide the data in two equal parts, right? So if you have a data and you want to divide your whole data in four equal parts, so you need 3 points to divide your data in four equal parts. So whenever we are interested in knowing a point which is dividing a data in two equal halves, we are calculating the median. Okay, so median divides it is a middlemost observation which divides your whole data in two equal parts basically. So for different types of data sets, like we have individual series of data or raw data which we use as it is, or we have ungroup frequency distribution or group frequency distribution. Okay, so when you have a number of observations and you are using the observations as it is, you are saying that such a data is raw data or sequence of observations you have. So let's see how to do the calculations when you have a raw data. First, see the disadvantages of median. It is not based on all the values. Okay, so while calculating median, you are not using all the values. It is not capable of further mathematical treatment. So we have the three measures of the central tendency: mean, mode, and median. So the first one, that is arithmetic mean, is the only measure of central tendency which we use for the further mathematical treatment or calculations. Okay, in case of even number of values, it may not have the value from the data. So if you have even number of observations in a data, whatever your median may not be in your data set. So these are the formulae we used. Median denoted by capital M or MD, that is the middlemost value. Okay, so let's take example and try to solve it. Okay, so we have basically odd number of observations. This is a formula for ungrouped data. It means when you have the individual observations, you have just series of observations like this. In this example, the scores are 16, 10, 15, 5, 17, 2, and 19. So when you have such a type of observations, if these observations are odd in number, you have a different formula for calculating a median. And if these observations are even in number, that time you are using a different formula for the calculation. Okay, so here how many observations you have? 1, 2, 3, 4, 5, 6, and 7. 7 means odd number, right? So here, what is the formula for odd number? in case of odd number, the median is n plus 1 by tooth observation. So n is number of observations you have. So let's say here in this case, odd number of data, odd number, that is 7, right? So your n is 7. So by using the formula, you can do the calculations like 7 plus 1 divided by 2. Tooth observation when data is arranged in order. Okay, so first thing you have to do, you have to arrange your data in increasing order or decreasing order. So here in this, we have arranged the data in decreasing order. So 7 plus 1 divided by 2 means 7 plus 1 is 8. 8 divided by 2 is fourth observation when your data is arranged in order. Order means any order, either increasing order or decreasing order. So here, if the score is like this, you are arranging in decreasing order, and fourth observation is your median. 1, 2, 3, 4. So 15 is your median here. Okay. So clear with this, when you have odd number of individual observations, your median is n plus 1 by tooth observation when the data is arranged in order. Now, this is a second example. Here you have, again, you are finding the median. So first, see how many observations you have. 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 observations, right? So your small n is 8 here. Small n is 8. So you have even number of observations, right? Even number of observations. So in case of even number of observations, your median is n by tooth observation plus n by 2 plus 1th observation and divided by 2. So you are taking mean of these two observations, n by 2th observation and n by 2 plus 1th observation when your data is arranged in order. When data is arranged in order, any order, increasing or decreasing. So what is n by 2? N by 2 is 4 here. N by 2 is 4 plus 1 is 5th observation. So your 4th observation plus 5th observation divided by 2 is your median. So you have to arrange your data either in increasing order or decreasing order. So here I have arranged in decreasing order. So fourth observation, this is 1, 2, 3, 4. So this is fourth observation and this is your fifth observation. So when you take a mean of these two observations, you are adding these two observations divided by 2 and this is your answer 15.5. Okay. So your X bar is 16 plus 15 divided by 2. You are taking the mean of two middlemost observations and that is your median. So in this case, your median is 15.5. So when we were seeing the disadvantages of median, the third point is what we have seen is in case of even number of values, it may not be the value from the data, right? So here for even number of observations, when there are 8 observations, what is your median? Median is 15.5 and that is not the observation from your data. Okay. So this is the case when you have to find out the median. So the next one is, this is the formula we use when you have group frequency distribution. So when you have observations, classes in the first column and respective frequencies in the second column, this formula you are using when you have classes in the first column and respective frequencies in the second column. So what type of a data you have? You have a data like this. So in this case, in first column, you have the marks, the classes 0 to 4, 5 to 9, 10 to 14, 15 to 19, 20 to 24. So these are the classes. And number of students is the frequency column. So when such type of a data you have, and you have to, you are finding the median, that time this is the formula you're using. So median is equal to L, or L1 is the lower class limit, or L is the lower class limit, plus n by 2 minus cumulative frequency of the previous class divided by the frequency of median class into H is the class size, or you can say L2 minus L1. So let's see in detail what it is. Okay. So I'm writing few of the classes here, 0 to 4, 5 to 9. Let me write here. 0 to 4, 5 to 9, 10 to 14, 15 to 19. Twenty to 24. What is the frequency? 2, 8, 14, 17, 9. This is 4, okay? This is 4. This is also 4. So these are the classes you have. This is a 4 frequency. Okay. So when you have such kind of a data, you have the classes in the first column and respective frequencies in the second column. That time, this is the formula. So what is your L1? Your L1 is lower limit of the median class. So what we are finding the median, right? So we are interested in knowing the middlemost observations. So how many observations we have? For that purpose, we have to do the total of the frequencies. Then only we can understand how many observations are there in this particular data. So 8 plus 2 is 10, 10 plus 14 plus 17 plus 9. So the total is 50. Okay, so this is your capital N now, means total number of observations. So we are finding the middlemost observation. So you are interested in knowing 25th observation. If you have total 50 observation with you, you are interested in finding out the middle observation, that is 25th observation, right? So for finding 25th observation, N by 2 means 25th observation. So your N by 2 is 25, right? So frequency means frequency of the median class. So what is the median here? How to find out it? For finding out the median, first you have to find out the cumulative frequency. So what is the cumulative frequency? Cumulative frequency means frequency up to the upper class limit. So 0 to 4, how many observations are there? 2. Then up to 9, how many observations are there? Up to 9 means below 9, how many observations are there? 8 plus 2, that is 10. Below 14, how many observations are there? Below 14, there are 14 plus 8 observations, right? 14 plus 8 plus 2 observations, that is 24 observations. Below 19, below 19 means you have to add all the observations till 19. So 17 plus 20, 14 plus 8 plus 2 is the total number of observations you have up to 19 or below 19. So here 24 plus 17. 41. Below 24, how many observations are there? Below 41, all observations are, below 24, all observations are below 24. So total number of observations below 24 are 50. So this way we can find out the cumulative frequency. So whenever we have the cumulative frequency and we are using this formula, so whatever given here is your N by 2, N is total of the frequency, that is 50 here. By 2, you can do 25 minus cumulative frequency of the previous class to the median class. So first we have to find out the median class. So what is the median class here? You are interested in finding 25th observation, which comes somewhere here. Below 14, there are 24 observations, right? So in this class, your 25th observation will come because below 14, there are 25 observations, right? So your 25th observation will come in the next class. So this is the median class. So first you have to find out the median class. So median, once you have the median class, the lower limit is your L1 or L. The upper limit is your L2. This is your frequency of the median class, that is 17. And you're interested in knowing the cumulative frequency of the previous class. So this is your CF. Once you have all these values, you're simply putting the values in the formula and finding out the answer. So here L or L1 is your 15, right? So can you use this as it is? No, you cannot use it as it is because the classes are discontinuous. So before using this for finding out the median, you have to make your classes continuous. Okay. So as this number is 14, this number is 15. First thing you have to do is you have to make your classes continuous and then only you can use it. Okay. So 14 plus 15 divided by 2 is 14.5. 14.5 is your L1. Or you can add one more column here. You can write down the continuous classes and from that classes you can take the values. Okay. So once you have all the information, you're simply putting the information in this formula and finding out the answer. What is your H? H is the class size. Means upper class boundary minus the lower class boundary. These are the limits, right? So these limits are discontinuous. So you have to make them continuous and then you have to take a difference of the L2 minus L1 and that is your H. So let's do it here. So again, I'm writing the continuous classes over here. That is 4.5, 4.52, 9.5. This will become 9.52, 14.5. Then here 14.52, 19.5. For this class, 19.5 to 24.5. So, and the respective frequencies, again, I am writing. The frequencies are 2, 8, 14, 17, and 9. So this is the frequency. These are the classes. And I'm again writing the cumulative frequency here. So your cumulative frequency is 2, 10, 24, 41, and 50. So what is the formula for the median? Median is equal to, now this is your capital N is equal to 50 here. So your N by 2th class is somewhere here. So this is your median class. Median class. Okay, so I'm writing each of the value here now. What is your L1? L1 is the lower class boundary or class limit for the median class, that is 14.5. Okay, so what is your L2? L2 is 19.5. So in our formula, we have used the H. So what is your H? H is L2 minus L1. So you can directly find out and write down the answer. So your H is 5. So what else you need? You need a cumulative frequency. Now this is your model median class, right? This is your median class. Okay. So cumulative frequency of previous class. So this is your CF. Your CF is 24. So this is your frequency of the median class. So your F is 17. So you are putting all the values now. So your formula is L1 plus N by 2 minus cumulative frequency of previous class upon frequency of median class into H. Now you have all the values. You are just putting the values here. The L1 is 14.5 plus, what is your N by 2? N by 2 is 25 minus cumulative frequency of previous class is 24 divided by the frequency of your median class is 17 into 5. So when you solve this, this is your answer. Kindly solve this and tell me the final answer. The answer is 5 by 17 plus 14.5. Now simple calculation is required, that is 5 divided by 17. 5 divided by 17 is 0.294. So if you add this, you will get your answer. 25 minus 24 is 1, right? So 1 into 5 is 5. 5 divided by 17 is 0 0.294. Just check it. Calculator. 5 divided by 17. 0.294 plus 14.5. 14.794. Yes. So this is how we do the calculations if the classes are given. Okay. So we'll move further. Now we'll learn more about the mode. Okay, so this is the third measure of central tendency. What is the mode? Mode is the value which comes with the maximum time in your data set, or which repeats the maximum time in your data set. So simply mode is the maximum frequency from your data set. Okay, so mode is the value which occurs the most frequently in your data set, most popular value in your data set. So advantages of mode, it is readily available, easy to calculate. It is not affected by extreme values. Disadvantages of mode are, it is based on all the observations. So when you change one of the observations, your value will change. Sorry, it is not based on all the observations. So when you change one of the value of the mode is will not change, because this value is the value which is coming more frequently in your data. Okay, it is not capable of further mathematical manipulation. So we are not using mode for further mathematical treatment or for further in mathematical calculations. We just use the arithmetic mean. Mode is affected to a great extent by sampling fluctuations. So when you are taking a sample and you are finding out the mode, you will get the different values of the mode. Choice of grouping has great influence on the value of the mode. So if you are grouping your data, it will influence on the mode. Okay, so what is the mode? Mode is the value which is repeating maximum number of times in your data set. So let's see how many observations you have here. This is example. In a crash test, 11 cars are tested to determine what impact speed was required to obtain minimal bumper damage. Find the mode of the speeds given in the miles per hour below. So speeds values are given. So values are 24, 15, 18, 20, 18, 22, 24, 26, 18, 26, 24. So you are requested to find out the mode. Okay. Or first you have to order the data so that you will come to know easily which value is repeating how many times. Okay, so once the data is arranged, here you can easily see that your value 18 is repeating 3 times, as well as 24 is repeating 3 times. So in this particular data, you have two modes. Your data can have multiple modes, single mode or two modes, or more than two modes, but generally we have a single mode or two modes. So when your data has a single mode, you are saying that unimodal data is there, and when your data has the two modes, you're saying bimodal data. So this is example of bimodal data. Okay, so if the values are like Can you tell me what is the mode here? You have to find out. One is coming how many times? One is coming just once. How many times two is coming? Two is coming two times. How many times three is coming? Three is coming three times. How many times four is coming? Four is coming two times. Five is coming one time. Six is coming one time. Seven is coming two times. Eight is not there. Nine is coming one time. So what is value of mode? Mode is the value which repeats maximum number of times. So three is your mode. Correct. Now if the data is like this. So now can you tell me what is the mode here? This is 7, okay? This is 7. Can you tell me? Yes. 7 is the mode because 7 is repeating 9 times in your data. Your frequency are the values which are telling you how many times your observation is repeating in your data set. So here your number 2 is repeating 3 times, 5 is repeating 5 times in data set, 7 is repeating 9 times, and 9 is repeating 7 times. 11 is repeating 4 times in your data set. So ultimately, which number is repeating maximum number of times? The number with highest frequency, that is 7. So this formula we use when we have group frequency distribution, like we have classes in the first column and we have respective frequencies in the second column. So this is the formula. L1 is the lower limit of the modal class now. Now we are finding out the mode. So we are interested in knowing the first modal class, like we were finding the median class where when we were calculating the median. Now first we will try to find out the modal class. Then the lower limit is L1, that is L. Frequency of the modal class is F1, frequency of a previous class is F0, and frequency of the next class is F2. And your H is the difference between uh, upper class limit and lower class limit of the modal class, that is L2 minus L1 for the modal class. Okay, so let's take example. Now this is example. Now here in this case, again, the classes are not continuous. If the classes are not continuous, first thing you have to do is make it continuous. So let's write 0.5 to 3.5, then 3.5 to 6.5, 6.5 to 7.5, 7, sorry, 6.5 to 9.5, right? 9.5. So 9.5 to 12.5 for this 12.5 to 15.5. The next one is 15.5 to 18.5. Then 18.5 to 21.5 and so on. I'm not writing all the classes. So how to find out the modal class? Modal class is the class with maximum frequency. So here the maximum frequency is here 8, right? So this class is your modal class. So you are using these are your limits, 15.5 to 18.5. So what is your frequency? This frequency of the modal class is your F1. The previous frequency is your F0. The next frequency is your F2. So they are in line, F0, F1, F2. Now you can, again, this is your L1. This is your L2. And your H is your L2 minus L1. So that is 18.5 minus 15.5. That is 3, right? So write down the formula for mode. Mode is equal to L1 plus. What is the formula? L1 plus F1 minus F0 divided by 2 times F1 minus F0 minus F2 into H. F1 minus F0 divided by 2 times F1 minus F0 minus F1. So first you are doing all these calculations and then adding it to the L1. So simply you can 15.5 plus. What is your F1? F1 is 2. Sorry, F1 is 8. F0 is 2. 2 times F1. 2 times F1 means 2 into 8 minus your F0 is 2 minus F1 is 1 into H is 3. Now do the calculations and tell me the answer. 15.5 plus 6 divided by 16 minus 3. Into 3. So your answer is 15.5 plus 18 by 13. 18 divided by 13. That is 1.384. You're adding to 15.5. So 15.5 plus 1.384. The answer is 16.884. So this is how you do the calculations for the finding out mode when you have classes and frequencies given, means your data is grouped frequency distribution. Now, if there is one more class, okay, if there is one more class, L1 value, Aman, can you explain what you're asking? Your F1 is 8. Why F1 is 8? This is the model class frequency. F1 is your model class frequency. That is 8. Here you can see, this is your model class, right? This is your model class 16 to 18. When you make this continuous, that is 15.5 to 18.5 is your model class. So frequency of that class is your F1. The frequency of the previous class is your F0 and frequency of the next class is your F2. So what is this? F1 is the frequency of the model class. F0 is the frequency of preceding the model class. F2 is the frequency of the class succeeding the model class. Hope you are clear with your query. So this is all about mode. These are the properties of mode. It is used when you want to find out the value which occurs most often. It is a quick approximation of the average. It is an inspection average. So it is when it is not possible to find out the average, or you want to make an average by just looking at it, rather than going from for a actual finding average. Sometimes people use the mode, means the maximum observation, as the average. So here we are finished with the unit 2, that is measures of central tendency. One more thing I want to tell you is when you have classes, and you have frequencies. Okay, so if you have the example like this, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30, and 3, 4, 5, 5, 2. Now, in this case, you have two model classes, right? Because you have 5 is coming 2 times, 5 is the maximum frequency. So you need to find out the mode for this class. You need to find out the mode for this class. If both the modes are same, you're saying unimodal. Your data is unimodal if both the modes are same. If both the modes are different, you are saying you have two modes. Your data is bimodal. So in such kind of examples, when the two frequencies are maximum, or the maximum frequency is repeating 2 times in your data set, let's say, so you are separately finding out the mode for each of the class. So I have given you example based on this on basically this particular situation in your assignment, that is a formative assignment which you are submitting from your home. So when you go through your assignment, multiple choice multiple response question, you will face this problem. In that problem, your frequency is repeating 2 times, so you can solve it in this manner. If your mode, both the modes are same, you're saying your data is unimodal. If both the modes are different, you're saying that your data is bimodal. Clear with this? So now we'll move to the unit 3, that is measures of dispersion. So measures of dispersion means you in measures of central tendency, what we are interested in knowing a single value which is representing your data. Okay, so now generally what we use, arithmetic mean is the value for further mathematical calculations. So now we are interested in knowing how our observations are scattered around the mean. As we are using the arithmetic mean for further mathematical calculations, we are interested in knowing how our all other observations are located around the mean. So we want to know the how the data is scattered, how it is dispersed, and we want to know a single value, and that is a measure of dispersion. Okay, so when you are interested in knowing how your data is scattered around the mean, you are basically interested or in finding out the mean deviation from the mean, or variance or standard deviation, or a range gives you how your data is scattered. So basically how your data is dispersed is given by the measures of dispersion. So you have different measures under this range. You have mean deviation, about mean, mode, median. You have the variance, you have standard deviation, coefficient of variation. So in this particular session, we are learning more about variance and standard deviation, because these are the two, you can say, the measures of the dispersion which we use for the further mathematical calculations. So the important one to know the calculations about the variance and standard deviation. So what is the range actually? The range means how you, what is the, like this, in this, we'll take the same examples. Here, what is the range? The maximum observation is 30, right? And the minimum observation is 5. So your range is 30 minus 5. Like in this case, the maximum observation is 30, the minimum is 1. So the range is 29. In this case, the maximum observation is 26. The minimum observation is 15. So your range is 26 minus 15. That is 11. So by looking at your data set, you when you subtract the minimum observation from the maximum observation, you can easily find out the range. Okay. So in this case, 24 minus 0, that is 24 is your range. Okay. So let's go further. So what is the variance? Basically, we are interested in knowing how your observations are located around the mean. Okay, so if the difference between the observation and the mean is more, you will, in calculations, you will find out the larger variance. If the distance between the mean and your observation is less, when you are doing calculations, you will observe the variance is less. Okay, so basically what we are doing, we are interested in knowing, let's say, let's take a simple example. X1, X2 and X3 are the three observations. Okay, 2, 3, 4 are these three observations. So when you find out the mean, what is the mean? 2 plus 3 plus 4 divided by 3. So here 3 is your mean. So you are interested in knowing how, what is the difference, or how, what is the distance between the observation and the mean. But when you take this deviation, x1 minus x bar, x2 minus x bar, x3 minus x bar. What is your x1? 2. 2 minus 3. X2, 3 minus 3. X4, 4 minus 3. So minus 1, 0 and 3. So if you take a summation of this, it will always come 0. So when you take a deviation from mean and take a summation, it always comes 0. But you need some number which is telling you about the deviation from the mean. So what, for finding out some positive value, you have to make this number positive. Then only you can find out some value here. So we have two mathematical functions basically, which converts your negative value to the positive value. The one function is mod function and the second function is square function. So whenever you are using the mod function and finding out the mean, you are calculating mean deviation about the mean. But we are not learning the those calculations now. What we are interested in knowing the formula of the variance. So the second mathematical function, when you square it, when you square any negative number, you will always get the positive number, right? So what we are using here is we are squaring it. Okay, we are squaring it to get some positive answer. So what will happen? You're squaring it. So what is the answer? Minus 1 square is 1, 0 square is 0, 1. So when you square it and find out the mean, you are actually calculating the variance. Okay, so this is the formula of the variance. What we have done, we have taken the deviation from the mean. When you take a deviation from mean and take a summation, it always comes 0. So we need to convert, we need to use some mathematical function which gives us the positive value. So we have used this mathematical function, square function. So we are squaring each of the deviation taken from the mean, and you are finding out the mean of it. And this is the value, or this is the formula for your variance. Okay, so here the variance is 1 plus 0 plus 1 divided by 3. That is 2 by 3 is variance for these three numbers, 2, 3 and 4. Okay, so what is the formula of variance? Variance formula is, the simple formula for variance when you have individual observations is summation xi minus x bar square divided by n. So this is your formula for variance. Okay, this is the formula for variance when you have individual observations. Now we have different formulae when you have a group frequency distribution, when you have group frequency distribution. So I'm writing the formula here. When you have so let's say you have individual numbers. Which formula you will use? Variance is equal to summation x minus x bar square divided by n. So when you have a group frequency distribution like 2, 3, 4, and you have respective frequencies like 5, 7, 3, and so on. So when you have such type of a data, your formula for variance is summation fi. Fi means frequencies, x minus x bar square. So here n will replace by the summation of the frequency. So this is the formula we use when you have a group frequency distribution. Then the next one is group frequency distribution. So when you have a data like this, like and so on. So when you have such type of data and you are calculating the variance is summation of fi, same formula we are again using here, x bar square divided by summation of fi. So these are the original formulae we have for the variance. We have again computational formulae available, but I'm not confusing you by bombarding so many formulae. You can remember this if you are using Excel. The directly functions are available when you want to find out the variance in case of the individual observations. Means if you have individual observations and you are interested in knowing mean, mode, median, variance, standard deviation, all the functions are available in Excel. If such kind of a data is there on group frequency distribution or group frequency distribution, you need to remember the formulae, you need to do the calculations, and you need to find out the answer for the variance. So this is about the variance. Now, if these observations are in centimeter, let's say these observations are in centimeter, 2, 4, 6, 8, 13, all these observations are in centimeter. I have measured it in centimeter. So while doing the calculations for variance, what we have done, we have squared here. So the answer of the variance is in centimeter square. But we are interested in knowing the original unit, and that is why we are calculating the standard deviation, which is a root of variance. And it carries the same unit of the observation, that is centimeter. So root of variance is your standard deviation. Again, standard deviation is root of variance here. So once you know the variance, root of variance is your standard deviation. So Carl Pearson introduced the concept of standard deviation in 1893. It is far the most important and widely used measure of dispersion. So most of the times we use the standard deviation because it carries the same unit of the observation. Okay. The standard deviation is also known as root mean square deviation, as it is the square root of means of squares of deviation taken from arithmetic mean, that is the variance. So what is the variance? Variance is means of squares of deviations taken from arithmetic mean. And when you take a root of variance, you will get the standard deviation. So we denote it by the capital SD or sigma, or when you are doing the calculations for population, generally we use the Greek letter sigma, and when you are calculating the standard deviation for the sample, we use a small letter s. So this is about the standard deviation. The formula is square root of variance. Okay, so whatever the formula we have written here for the variance, when you take the square root of it, you will get the standard deviation. So the same formula of the variance I have written in the square root, and that is your standard deviation. You always denote it by the sigma when you are calculating it for the all observations in your population. This is your standard deviation. So find out the standard deviation for the following data. So we have a data 5, 6, 3, 2, 4, and we are expected to find out the standard deviation. So for finding out the standard deviation, first you can calculate the variance, or you can directly do the calculations in under root and directly find out the standard deviation. But it is better always to write down. So what is the formula for sigma square? Sigma square is you have individual observations, right? So what is your formula? X minus X bar square divided by N. How many observations you have? 5 observations, right? So first, what you need here is X bar. So first calculate the X bar. What is X bar? Your X bar is summation of Xi divided by N, where your N is 5. So what is summation of Xi? I have already done here, that is 20. Here the summation is 20. So 20 by 4 or 5 is 4. So your mean X bar is 4. X bar is 4, right? So what you're doing, you are subtracting mean from each of your Xi. That is X minus X bar. Okay, X minus mean means X minus X bar you are calculating. 5 minus 4 is 1, 6 minus 4 is 2, 3 minus 4 is minus 1, 2 minus 4 is minus 2, 4 minus 4 is 0. But you don't need, if you do summation here, it will come 0. You don't need 0, right? You need some value. So we are using the formula of variance. So we are squaring it. So you're squaring it here, X minus X bar square, and that is 1 square is 1, 2 square is 4, minus 1 square is 1, minus 2 square is 4, 0 square is 0. And this is your numerator. So your answer is 10 divided by number of observations, 5, that is 2. Your sigma square is 2, so your sigma is root 2. Clear with this? We have remember, we have calculated sigma square and not the sigma. You are expected to find out the standard deviation. So standard deviation is root of variance. This is the formula for ungrouped frequency distribution. Standard deviation is root of variance. I've written the formula of variance here. So this is the case, or this is the example for ungrouped frequency distribution. The marks are given in the first column and respective frequencies are given in the second column. So what is given here? The given here is your one is there are 2 students who have scored 1 mark. There are 5 students who have scored 2 marks. 7 students have scored 3 marks. 3 students have scored 4 marks, and 3 students have scored 5 marks. Okay. So these are the frequencies and these are the individual observations. So these are your Xi's and these are your Fi's. So first thing you have to find out X bar. I'm taking a break of 1 minute. I shall come back. The battery is low. We'll continue. So first we have to find out the X bar. Xi's are given, Fi's are given. So what is the formula in K? What is the formula for finding out X bar? That is mean when you have ungrouped frequency distribution. The formula is summation of Fi Xi divided by summation of Fi. So what is, these are the Xi's, these are the Fi. So you are finding the Fi Xi by multiplying these 2 columns. 1 into 2 is 2, 2 into 5 is 10, 3 into 7 is 21, 4 into 3 is 12, 5 into 3 is 15. So your Fi Xi you have total is 60. So 60 divided by summation of frequency is 20. So your answer is 3. So your X bar is 3 here. Once you have your X bar, what you need to find out, you need to find out X minus X bar. So this column gives you the values of X minus X bar. What you are doing, X is 1 minus 3 is minus 2, 2 minus 3 is minus 1, 3 minus 3 is 0, 4 minus 3 is 1, 5 minus 3 is 2. What you need fi xi square. So you are squaring it. 21014, but you don't need this column. You have frequencies now, so you are multiplying each of the observation by the column in the frequency. That is fi into xi minus x bar square is required here. What is your variance formula? Variance is summation of fi xi minus x bar square divided by summation of fi. So you have this. So you need this calculation. So we have already done the calculations up to x minus x bar square. So I'm multiplying this column and this column to get this last column. So 4 into 2 is 8, 1 into 5 is 5, 0 into 7 is 0, 1 into 3 is 3, 4 into 3 is 12. And total of this column is your numerator now. So that is 28 divided by 20. 28 divided by 20. So what is the answer? 1.4 is your variance. That is your sigma square is 1.4. Sigma square we write by sigma square is your variance. So your standard deviation is your sigma, and that is root of 1.4. That is 1.18. So this is how you can do the calculations for the variance and standard deviation when your data is ungrouped frequency distribution. That is, you have individual values in first column and respective frequencies in the second column. So formula for grouped frequency distribution, the same formula. Now you have the classes are given in the first column and respective frequencies are given in the second column. Okay. So you are interested in finding out the standard deviation. So for finding out the standard deviation, first thing you have to do is here the classes are given, right? So values of xi's are not there. So when the classes are given, first you have to do is you have to find out the xi's, and your xi's are your mid value. So how to do the calculations for mid value? Your xi. Okay. 20 plus 0 divided by 2 is 10. For the second class, the mid value is 30. Third one, the mid value is 50, then 70, and then 90. Right? These are your mid values. So now you're using these xi's and these frequencies for your calculation. Okay, so you have xi's like 10, 30, 50, 70, 90 and respective frequencies. So I have written here xi's and respective frequencies. Once you know the fi and xi, you can do the rest of the calculations. What is your x bar? X bar is summation of fi xi divided by summation of fi. So fi xi summation means 10 into 2 is 20, 30 into 3 is 90, and so on. So the total is 1080 divided by the total of frequency is 20. And if you do this, the answer is 54. Kindly check the answer. 1080 divided by 20. Yes, 54. So you have now x bar. So the next column is x minus x bar, right? So x minus x bar, that is, what is your x? X is 10. 10 minus 54, that is minus 44. 30 minus 54. 30 minus 54 is minus 24. 50 minus 54 is minus 4. 70 minus 54 is 16. 90 minus 54 is 36. You don't need this. What you need, you have to square this. So 44 square is 1936. 24 square 576. 4 square 16. 16 square 256. 36 square 1296. So again, you don't need this. What you need is you need to multiply this column by the frequencies column, and that is your last column. So 1936 into 2 is 3872. 576 into 3 is 1728. 16 into 7 is 112. 256 into 5 is 1280, and the last one is 3888. So you need the summation of this. The summation is 10,880. So what is your formula for variance? Fi x minus x bar square divided by summation of Fi. So this is your numerator. Divided by 20. So this is your variance. So you can denote your variance by sigma square. Okay. So this is your sigma square. So your sigma is standard deviation, and that is root of 544, and that is 23.32. So can you do the calculations for this and tell me the answer for variance and standard deviation? If all the measurements are in centimeter, your variance is coming in centimeter square, and your standard deviation unit is centimeter. Do the calculations and tell me the answer. This is the last example from this third unit. So in the next session, we'll start with the next unit. I'm sharing a link with you. Kindly go to the link and share your feedback. Do the calculations and tell me what is the answer. Yes, variance is 2 and your standard deviation is root 2. That is 1.41. So your standard deviation is 2 centimeters square, and variance is 2 centimeters square, and standard deviation is 1.41 centimeter. Ania, check your answer. The answer is 2 and root 2. Sorry, Ananya. So what is your X bar here? Your X bar is 20 by 5. That is 4, right? So this is x minus X bar. 5 minus 4 is 1, 2. Then 3 minus 4 is minus 1. 2 minus 4 is minus 2. 4 minus 4 is 0. So you need x minus x bar square. It is 1, 4, 1, 4, 0. So the total is 10. So your variance is summation of x minus x bar square divided by n, that is 10 by 4. Have I done any mistake? 5 plus 6 is 11. 11 plus 3, 14, 15, 16, 17, 18, 19, 20. 20 by 5 is 4. Plus 4 is minus 1, 2, minus 4 is minus 2, 1. Sorry, n is 5. So your variance is 2 and standard deviation is √2. So number of observations 5, 10 by 5 and 2. So we are done up to this unit. I'm ending today's session. See you in the next session.